Welcome to homework.
In this question, the motive is to determine if the mean of the first sample is greater than the mean of the second sample at the given significance level. So our first step would be to write the hypothesis. So here the null hypothesis is mu1 is equals to mu2, that is the mean of the two populations are equal, while the alternate hypothesis will be mu1 is greater than mu2. It means that the mean of the first population is greater than the mean of the second population. Now let us write the given information, such as the value of sample size is 5. Now the value of standard deviation for the first sample is 4 and the value of sample size for the second sample is 7 and the value of standard deviation for the second sample is 5. So the value of pooled standard deviation denoted by SP will be here equals to, let us write the formula for it, and the formula is n1 minus 1 multiplied with s1 raised to the power 2 plus it is here n2 minus 1 and then it will be s2 raised to the power 2 and in the denominator it will be n1, then it is plus n2, now it will be minus 2. So if we plug in the value, then it is going to be equals to 4.626 approximately. Now let us calculate the value of test statistic, but firstly we will write the value of x1 bar, which is the sample mean. So it is equals to 41 and the value of x2 bar, that is the value of sample mean for the second sample, is 31. So the formula for test statistic will be here T and then it is here x1 bar minus it will be here x2 bar, and in the denominator we are going to have the expression which will be, let's write it is here SP and then it is square root, and inside the square root it is 1 divided by n1 plus it will be 1 divided by n2. So the value of test statistic will be equals to, it is going to be 3.6 and then it is 92. So this is an approximate value that is obtained after plugging the value into the given expression. Now let us calculate the T critical value. So it is the value associated with alpha divided by 2 comma degrees of freedom, and it will be approximately 2.764, and we are having the value of degrees of freedom as n1 plus n2 and then it will be minus 2. So this value is 10 and the alpha value is 0.01. So that's how we have calculated the T critical value, and we can also mention the Excel command that we have used over here. So this is a right tail test since the alternate hypothesis contains the symbol of greater than. So the Excel command will be t.inv. Now it is 1 minus alpha comma degrees of freedom. So this Excel command helped us to calculate the above T critical value. Now let us compare the T critical value and the test statistic value. So the test statistic value, which is equals to 3 and then it will be 692. So this is greater than the T critical value, which is approximately 2.764, and hence we can say that the test statistic value lies in the rejection region. So the decision will be to reject the null hypothesis. So here it is reject and then it will be H0, that is null hypothesis. So let us write the conclusion, and the conclusion will be that there is enough, and then we can write evidence at the given significance level, or we can say the given value of alpha, which is equals to 0.01. It can be concluded that the mean of the first sample is greater than the mean of the second sample. So it will be our conclusion, and we can put the answer inside the box. And now we will proceed towards the pooled standard deviation and the distance between means. So pooled standard deviation and the distance can be obtained by writing the formula for distance here, and it will be x1 bar minus it is here x2 bar, and in the denominator it is pooled standard deviation. So this value will be 41 minus 31 divided by 4.626, and it is here approximately 2.162, and hence we can say that the distance between the means in terms of the pooled standard deviation is written before us. So this distance shows how many standard deviation the difference between the two means is from the pooled standard deviation. So let's write over here the answer, and it will be 2.162, and we can put the answer inside the box, and that's all for this very video.